In both the program, both the diagrams you observe. In is a relationship, how many objects are there? One object. Okay, one object is there. But which class object is there? B class object is there. In that B class object, A members are present or not present? Present. But is there any A object? No. In this diagram, how many objects are there? Two objects are there. A object, B object. Okay. A members are present in A class. B members are present in B class. Both we can see, both are there. But there only one. Now, one general example, understanding purpose. Relation is there or not, give answer. After that, which relation is there, give answer. Is a or has a. Okay. Suppose apple and fruit. Apple and fruit. Relation is there or not? Yes or no? Yes. Which relation? Is a. Apple is a fruit. Apple is a fruit. Can we see apple? Can we see apple? Yes. Can we see fruit? Can we see fruit? Apple is a fruit, but fruit we cannot see. Apple we can see. So, fruit and apple relation is there, but apple is a fruit. But where is fruit? Apple is a fruit. Now, B is a. You have seen. B is a. In the diagram, can we see A object? Fruit like a. Apple like a B. Apple is a fruit. Now, can we see fruit? No. Can we see apple? Yes. Fruit properties inherited in apple. Fruit properties inherited in apple. Okay. That's what apple is a fruit. A class properties inherited in B class. So, B is a. Like that. Understood? Say, in the diagram, how many objects are there? One. But how many classes are there? Two. A class is there, B class is there. Is there any A object? No. B object? Yes. A members are present in B object. Fruit and apple. Fruit properties are present in apple, but we cannot see fruit. We cannot see A object. There is no A object, but A members are present. But fruit doesn't appear. But fruit properties are present in apple. What do you want? Now, car and vehicle. Car and vehicle. Relation is there or not? Yes or no? Car is a vehicle or car has a vehicle? Car is a vehicle. Car is a vehicle. Vehicle properties inherited in car. Car, simple English only. Simple English. Car is a vehicle or car has a vehicle? Car is a vehicle. Can we see car? Can we see vehicle? No. Car only you are calling vehicle. But where is vehicle? Vehicle properties inherited in car. We cannot see vehicle, but we can see car. Between vehicle and laptop, any relation is there? No. Because vehicle properties are not present here. Vehicle means something required of brake, clutch, all those things. Those are not there here. So, between vehicle and laptop, there is no relation. There is no relation. No is a, no has a. Relation is not there. Between vehicle and laptop, there is no relation. Okay? Like that. Now, vehicle, car and wheel. Car and wheel. Relation is there? Yes. Which relation? Has a relationship. Car has a wheel. Can we see wheel? Can we see car? Here, as a relationship. Can we see A object? Can we see B object? Both we can see, no? A object we can see. B object we can see. Like a car we can see. Wheel also we can see. That type. Now, vehicle properties, how many times inherited? One time. How many wheels are there? 4. So, one time required is a relationship. More than one time required has a relationship. Like that, we have to select in real time. One time required is a. More than one time required has a. Now, vehicle properties. Vehicle properties. Vehicle means something required. That is how many times are present in car? One time. Wheel. How many wheels are present? More than one time. One time required, you have to select is a. More than one time required, you have to select has a. Suppose here. Now what I'll do, see here. Here. I want to make a relationship between A class and B class. Extends A. Can I write again extends A? Can I write extends A? No. How many times we can write? One time. This is a relationship. Now here AOB1 equal to new A. AOB2 equal to new A. AOB2 3 equal to new A. Can I write? Yes. N number of times you can create. So is a relationship how many times possible? Has a relationship? Many times. One time required, you have to select is a. Many times required, you have to select has a. Depends. Okay. Now, like this, is a has a relationship concept. Now, in real time, how to select? See. Suppose here, example 2. Here, example 2. Here also, example 2. Is a relationship side, example 2. Has a relationship side, example 2. Now, suppose class student 1, integer roll number, string name of the student, string address of the student, integer landline number. Okay. Now I want to add mobile number, mail ID. Class student 2. Here integer mobile number and integer string mail ID. Now these two I want to make a relationship. Otherwise, if you don't make a relationship, here whose mobile number, whose mail ID. Only mobile number, mail ID written, but whose mobile number, whose mail ID. Here at least what will happen? Whose address, landline, whose landline number means this person rule number, this person name, that person address will say. But here only mobile number, mail ID if you maintain, whose mobile number, whose mail ID. Okay, that's what roll number name required here. Roll number name how many times required? One time. Then which relation? Extends. This is. It is a relationship. Now roll number name how many times required in second student? How many times required? Student to class? One time. Then what we have to write? Extends. Okay. If 3 members not listening class. If 3 members not listening class. If not interested, you can leave. Attending class is wasted. Later, how to select also people are not selecting properly. This is all each and every word you cannot write. Okay. This you have to follow with examples, programs, code snippets, concept is all. That's it. My every word if you write daily one notebook will finish. Daily one notebook will finish. No. Is it possible to write every word? That's what you have to listen. Listening is important. So your roll number name, how many times required for year? One time. Then what you have to do? Extends. Extends is a relationship. Write this one. Up to exception handling, most important, listen with more concentration. See, later while attending advanced Java, you will realize. That's it. How much importance is there for core Java, you'll understand. Many people after completion of Spring Boot microservices, they'll understand the importance of core Java. After completion. Complete core Java, advanced Java, J2EE. After completion, all they'll realize. But later, if you realize, no use. Core Java most important up to exception handling. Most important. Same word I am saying in advanced Java class also. Advanced Java class also I'm saying same word. Core Java only important. Don't think like a core Java class, core Java important, advanced Java class, advanced Java important. Like that I'm not saying. Advanced Java class also I'm saying same word. Core Java only important. Which one? Extends. Student 1 again, right? Okay. Class student 1, here class student 2. Student 2 extends student 1. Here, what we'll do is, we'll create student 2 object. Student 2. Then memory allocated to both. Roll number, name, address, landline number. Mobile number, mail ID. These are student members. These are student 2 members. Student 2 object. It is referred by S. Student 1. In the above example, student 2 is a student 1. In the above example, student 2 is a student 1. In the above example, student 2 is a student 1. Between student 1 and student 2 is a relationship is there. Because here roll number name required only one time. If many roll number, many names required, then we'll write has a relationship. One person having one student roll number only. That's what one time required. One time required is a. More than one time required has a. In the above example, student 2 is a student. Student 1. So roll number name required for mobile number mail ID. Otherwise, whose mobile number, whose mail ID? Only if you maintain mobile number mail ID, mobile number mail ID. But whose mobile number, whose mail ID? That's what roll number name required. Roll number name required here also, here also. Okay. In student 1 class also required, student 2 class also required. Is it over? Here, how many objects are there? One object. Which class object? Student 2 object. In the student 2 object, student 1 members present or not present? Present. Student 1 members present in student 2 object. That's what relationship is there. Which relationship? Is a relationship. Is it clear? Now, I'll give one more. See. Suppose class address. Class name is address. string house number, string city, string house number, street, city, pin code. Okay, like this, 4 variables: address, house number, street, city, pin code. Class employee, here integer employee number, string name, string name. Now I want to make a relationship between address class, employee class. Now employee extends address better or creating address class object in employee class better? Address object creating in employee class better or extends address better? Extend address means how many addresses comes? One address. What about one employee can have two the address also? No? Permanent address, present address. Suppose example, our addresses, village address will be there, Hyderabad address will be there. Permanent, present. Two different addresses will be there. No? Permanent address, present address. Then which relationship has a extends? If you write, what will happen? One time address inherited, one time only comes. But instead of that, create object here, address 1. Okay, here create new address, address 2, new address. It is better. No? Employee has a address. Employee has two addresses. One is permanent address, one is present address. Now address, new address, these 4 memory allocated. New address, these 4 memory allocated. So 2 house numbers, 2 streets, 2 city, like that. 2 addresses will be there. One is permanent address, one is present address. So more than one, like this. In this situation, has a relationship. Right. Example 2, right side. Example 2. Example 2, right side. So address class contains 4 variables: house number, street, city, pin code. Employee equal to new employee. Employee equal to new employee. Then employee number memory, name, address 1, address 2. Here, house number, street, city, pin code. Here also, house number, street, city, pin code. These are address objects. This object refers like this. Address object. Here, address object. Now two addresses are there. Two addresses. Now a number of addresses you can create in this way. More than one, we have to select has a relationship. One time required is a relationship. It is the employee object. See, employee number, name, address 1, address 2. These all members of employee class. Now address 1, address 2. Members of which class? Employee class. That's what employee number, name, address 1, address 2. These all employee object members. Is it over? Employee number, name, address 1, address 2. Employee number, name, address 1, address 2. These all members of employee class. So employee object. Employee object having these four. Address 1 refers address object. Address 2 refers address object. Address object. Like house number, street, city, pin code, year also, year also. Okay. Is it over? Here address objects also we can see, employee object also we can see. But there one class object only we can see, subclass object. Writing is over. Note down. In the above example, employee has a address. In the above example, employee has a address. In the above example, employee has a address. Is it over? EMP has a address. Up to here, inheritance related concepts completed. Inheritance related concepts. Total how many object-oriented principles? 4. What are those? 4 principle, 1 principle completed. Okay. Next, polymorphism. Next heading, polymorphism. Okay. Now, how many relationships are there? 2. What are those? Is a, has a. Is a relationship refers inheritance. As a relationship refers composition. What is inheritance? Creating a new class from an existing class. What is has a relationship? Composition. Creating an object of one class as a member of another class. These definitions you have to give answer. Okay. But whatever I take in general example, don't give answers. Understanding purpose. Apple is a fruit and a car is a vehicle. Understanding purpose. Okay. Understanding purpose I given. If I teach pure technical, all people may or may not understand. That is the reason general example. Okay. With the general example, you got a clarity. That purpose I have taken, that's it. But general example, no one will accept in interview. Okay. Technical definitions only have to give answer. Now, next, polymorphism. Note on. The ability to take more than one form is called as polymorphism. The ability to take more than one form is called as polymorphism. Poly means many. Morphism means forms. And polymorphism means many forms. Poly means many, morphism means forms, and polymorphism means many forms. Overloading, overriding, you studied no definitions. That it comes under here only. Poly means many, morphism means forms, and polymorphism means many forms. What is method overloading? Two or more methods with the same name and with a different parameters list. Then it is said to be method overloading. What is method overriding? Same name, same parameters list. That is overriding. In both the cases, name same. Okay. Different parameters. Here different definitions will be there. Overriding. So more than one form. Suppose if I write here void add integer A, integer B. Void add integer A, integer B, integer C. Void add float A, float B. Now here method name add. Three methods add. Is it overloading or overriding? Overloading. Say poly means many, morphism means forms. Polymorphism means many forms. The ability to take more than one form is called a polymorphism. Here add method, three forms. This add method will add two integers. This add method will add three integers. This add method will add two floating point numbers. But in all the places, what is doing? Addition. Addition only, many forms. So here add method will add two integers. Here add method will add three integers. Here add method will add two floating point numbers. It lasts all the places. It is performing addition operation only, but many forms. So it is called polymorphism. Say you are speaking with parents, you are speaking with friends, you are speaking with faculties. Are you speaking same? Complete different, no? See, speaking with parents one type, speaking with friends one more type, speaking with faculties one more type, speaking many forms. You are speaking different forms. It is nothing but polymorphism. Okay. Suppose myself, I am teaching Java. Different places, different types I taught Java. Java only different forms I taught. For example, corporate training, that is one more type. Job seeker training, it is one more type. Academic training, it is one more type. See, here teaching only Java, different forms. Different forms I am teaching. So Java in corporate one type. Java here, job seeker training. Actually, your target is you want to get a job. For that, what is the record I am teaching? For already working employees, for them, what is required? That is I'm teaching. Academic training, that is one more type. That is one more type training. Project-based training, task-based training, different types of trainings handled. But what I'm doing, I'm teaching Java many forms. It is nothing but polymorphism. See, what this core Java, there I'm teaching in corporates 1 week only. 21 days, core Java, advanced Java, J2EE. 21 days. But here, if it is like that, it will not be worked out. Okay. Your target is you want to get a job. For getting job, what is the record? I'm teaching. This is one type. This is one type of training. Corporates, already they got a job. They're working. For them, different type of teaching. Like that, 21 days only, core, advanced, J2EE, daily 4 hours. It will finish. Their requirement is different. Okay. They'll schedule like that only. 21 classes, 21 days, daily 4 hours schedule they'll give. According to them, I have to teach like that. But whatever I'm teaching there, here if I teach, no one can understand. Here whatever I'm teaching there, if I teach, all will jump. Okay. No one will sit in my class like that. So here requirement is different. Their requirement is different. Okay. Whatever I'm teaching here, there if I teach, they won't listen because already they got these all. Already they know these all. They're one way different. But whatever I taught here, seeing the demo class only, all will jump here. They cannot understand. Whatever I taught in corporate, if I teach here no one can understand. Whatever I'm teaching here, there if I teach, they'll get a bore because already everything they know. Like that. So it is polymorphism. So teaching Java many forms. That is polymorphism. Here, add method, addition operation, it is performing with 2 integer. Addition operation with 3 integers. Addition operation with floating point, 2 floating point number. It is nothing but polymorphism. Many forms. Say, these polymorphism, 2 types are there. Note, there are 2 types of polymorphism. There are 2 types of polymorphism. First, compile time polymorphism. This is only we are calling like a static polymorphism. Here, runtime polymorphism. We can call it as dynamic polymorphism. There are 2 types of polymorphism. First one, compile time polymorphism. We can also call static polymorphism. Second one, runtime polymorphism. We can also call dynamic polymorphism. So polymorphism, 2 types. Compile time polymorphism, runtime polymorphism. 2 types of polymorphism. Now, first one, compile time polymorphism. Note down. Binding of method call statement with method definition is done at compile time is known as compile time polymorphism. Binding of method call statement with method definition is done at compile time is known as compile time polymorphism. Binding of method call statement with method definition is done at compile time is known as compile time polymorphism. Example, method overloading. How it will be compile time polymorphism, I'll explain. Example, method overloading. There are two types of polymorphism: compile time polymorphism, runtime polymorphism. Compile time polymorphism means binding of method call statement with method definition is done at compile time, is known as compile time polymorphism. Overloading comes under compile time polymorphism. Overriding comes under runtime polymorphism. I'll explain how. Example, method overloading. What is method overloading? Same name, different parameters list. No, not done. If two or more methods with the same name and with a different parameters list, then it is said to be method overloading. If two or more methods with the same name and with a different parameters list, then it is said to be method overloading. If two or more methods with the same name and with a different parameters list, then it is said to be method overloading. Parameters list can be different in number of arguments, comma, data types, or order of an arguments. Parameters list can be different in number of arguments, data types, or order of an arguments. If two or more methods with the same name and with a different parameters list, then it is said to be method overloading. Parameters list can be different in number of arguments, comma, data types, or order of an arguments. In method overloading, these all are given already. Once again, I'm giving. In method overloading, return type can be same or different. Can be same or can be different. In method overloading, return type can be same or can be different. Same also valid, different also valid. Method name must be same. Parameter list must be different. Return type same also valid, different also valid. That is method overloading. That is compile time polymorphism. How? I'll explain. How it is related to compile time polymorphism. These all already given. These all already given. If two or more methods with the same name and with a different parameters list, then it is said to be method overloading. Parameters list can be different in number of arguments, data types, or order of an argument. Either number of arguments or data types or order. Any one difference should be there. Okay. Then it is overloading. Now, here Return type same also valid, return type different also valid. Okay. Now, how it is related to compile time polymorphism? This point out explain. Say, is it over? Writing is over. Now. Say integer max which takes two integers. If A greater than B, return A, else return B. One more. Int max which will take three integers. If A greater than B and A greater than C, return A. If A is not greater, B greater than C, return B, else return C. Okay. If A greater than B and greater than C, then A is greater. If it is not, A is not a greater, either B or C. Okay. Now, it is max method. It is max method. Method name same. Here two integers. Here three integers. Parameters are different. Number of argument different. Here return type same. Same also valid here. Different also valid. If you want to call these methods, how will call? Demo d equal to new demo. Next, return type integer. Int x equal to d dot max. If I pass three integers, first method called or second method called? Second method called. System dot out dot println x. Next, int y equal to d dot max. If I pass two integers, which method called? First method called. Now you observe first method name max, method name max, method name same, parameter list different. It is called overloading. In overloading, same return type also valid, different return type also valid. But how this is related to compile time polymorphism? First, polymorphism or not? Max method two forms polymorphism. But how it is related to compile time polymorphism? Now you observe. You studied already. This totally called method definition. This line is called method call statement. Now what I given see? Binding of method call statement with method definition is done at compile time is known as compile time polymorphism. Here binding of method call statement. This is binding of method call statement with method definition is done while compiling. Say this statement is going to call max method. But max methods, how many max methods are there? Two. Which method is going to be called first or second? How it knows? With parameters list. Because parameter list must be different. No? Now based on that, it will decide. This method call statement bound with this definition. This method call statement bound with this definition. This binding done at compile time. This is called compile time polymorphism. Binding of this statement with this definition. Binding of this statement with this definition. When it is done compile time. That's what compile time polymorphism. It is polymorphism. Binding done compile time. That is compile time polymorphism. Write this one. Example. Example. This is method call statement. This is method call statement. This above methods, whatever is there, these all method definitions. Binding of method call statements with method definitions is done at compile time. That is called compile time polymorphism. So compile time polymorphism very simple, but runtime polymorphism not easy. You need to put efforts to understand. So it is a method call statement. It is a one more method call statement. Here also calling max, here also calling max. But two max methods are there. This statement bound with first, second definition. This statement bound with first definition. That binding done at compile time. That is called compile time polymorphism. Is it over? Say your method name same, but how it knows second method should be called? Parameters. Here first method based on parameters it will understand. Okay, based on parameters it will understand. This definition should, this call statement should call this second definition, this should call first definition. Like that it will decide. That is binding done at compile time. First method name same, parameter different, it is overloading. Polymorphism means many forms. Max method it is one form, it is one more form. But this binding done no at compile time. That is compile time polymorphism. Runtime polymorphism not easy. That is it will take 2-3 days. 2-3 days. That is tomorrow I'll start. So for complete runtime polymorphism, minimum 2-3 days required to understand. We'll see continuation tomorrow.